Okay, this video is about this guy right here named Glenn Jeffries. We're going to talk about his paper. I'll show you the paper on the screen. Basically, this little graphic here shows the idea of what he did. He exposed a patient's back to sunlight and the different specific wavelengths. Basically, over 600 to 1,000 nanometers wavelength will go through the human body, and it improves the function of the mitochondria. And after that, if you check an oral glucose tolerance test, their blood glucose levels are improved, their mitochondrial functions improved, their vision is improved. It's pretty impressive research. Okay. And basically, I've said it before that the way to be healthy is just to do what humans are supposed to do. You know, God put us on this earth like Adam and Eve. He said, I have made these plants. They will be food for you. We walk around in extended family groups outside looking for food all day long. That's what humans are made to do. And I used to think of it primarily from the point of view getting exercise, walking around outside. Yeah, you get your vitamin D, your nitric oxide precursors to vasodilate. But it also turns out from the sunlight you get improved mitochondrial function. That's a big thing. Okay, maybe that's why people in the old days aged longer, lived longer in the Bible. Okay, we'll talk about that, but there's some reason to believe that. Okay, here's just a quick look at the electromagnetic spectrum. And of course, what we care about the most is the visible light. It's only a small amount of the electromagnetic spectrum, okay? In this ballpark, 430 to 750 ballpark. The longer wavelengths are infrared. The shorter wavelengths are ultraviolet, okay? We're going to talk about what all that means in a moment. But in general, longer wavelengths penetrate things better. Shorter wavelengths, I'll explain what it means in a moment, because that's what I want to do is focus on the stuff that matters for us. I prefer to look at the spectrum like this. So ultraviolet, beyond violet, that's what gives you a sunburn. That's what gives you a suntan. That's what causes nitric oxide precursors to be released. Blue is how our brain knows that this is daytime. Okay, from the suprachiasmatic nucleus, the time clock in your top of your hypothalamus in your brain that sets your circadian rhythms. All right, red and then infrared, beyond red. So these are the longer wavelengths. So shorter wavelength is like ultraviolet light and blue. Longer wavelengths are red and infrared. Okay, here is another look at this sort of spectrum here. And again, they flipped it the other way, but infrared is beyond red. Ultraviolet is beyond violet in that direction. Okay, so the ultraviolet's like less than 400. The infrared's like more than 750. A common visible light you'll see used is 670 nanometers here of sort of just barely red light, and then you'll hear 850 nanometers of infrared light. Those are common things used in these experiments. Here's an important picture. You want to get this one. I'll make sure it's clear. You can hit print screen button if you want. The point of it is that a lot of these modern LED lights have a lot of blue light in them. Okay, halogen lights, the old-fashioned halogen light bulbs and incandescent light bulbs, they got way more red in them. Okay, sort of a more wider spectrum. Okay, and this one, a lot of these LED lights, they're specifically made to only produce visible light. And a lot of times they got a tremendous amount of blue light in them. So you don't want those in your house at night, because the blue light is perceived by your brain as daytime and they'll keep you awake. It's this infrared light over here that improves your mitochondrial function. Normal sunlight has got lots of infrared light. And as a matter of fact, Glenn Jeffries, he says that you want to buy incandescent lights, okay? These incandescent lights, they're like sunlight. So that's what you want. As a matter of fact, I just bought some incandescent lights for this reason. When you learn about it, you're going to want incandescent lights. You can buy them on the internet. Oh, another point that's made is it's way, way brighter outside in the sunlight. People sometimes think, they go out in the sun and it seems like the lighting's not that much brighter than in their house, but it's actually can be orders of magnitude brighter. And the reason is our pupils constrict when we go outside. So we don't notice how great a difference it is. Sometimes you'll see it if you're out in the sunlight, you come inside and the house seems kind of dark at first, so your pupils vasodilate upon entry into the house. But a typical light bulb in your house is not that bright. Like let's say around 200 to 500 lux. Outside, the sun can be 100,000 lux on a bright day. Okay, that's relevant for setting your circadian rhythms. That's why it's recommended, if you can, get outside a little bit first thing or before 9 o'clock in the morning when you wake up to get some of that sun exposure. So like I'll do things like where I work, I have a long walk to my hospital. So I'll intentionally park as far as I can in the parking lot so I get more time in the sun to walk. Okay? And that's good to do that, to at least get that much sunlight. And afterwards when I walk, instead of walking under a canopy, where you can, a lot of people will always prefer to walk under a canopy because it gives you shade and it protects you from rain, but I'll always walk in the path where there's no canopy because I want the sunlight. Okay, and I'm telling you, even short exposures to sunlight, he shows cases, Glenn Jeffrey, where people just get like 3 minutes of exposure to sunlight and they get significantly improved vision for a prolonged amount of time. Oh, this is just some more relative brightnesses measured in lux. You know, lux is like 1 candle at 1 meter of that amount of brightness. But again, the point is the same. Incredibly high levels of brightness when you're outdoors in the sunlight. Relatively little, like twilight, when you're indoors, okay? And then very little, of course, at night. But even an overcast day will have pretty high. Okay, now here's the paper. Let me get myself out of the way. So here's the paper by Glenn Jeffrey. And this is the title of the paper. Longer wavelengths in sunlight, they pass through the human body. They go all the way through the chest, and they put a detector in the back, and they will be able to measure the long wavelengths behind the patient. So it's going all the way through the patient. And it's interacting with mitochondria along its way, and it's improving their function. It's thought that the red light, infrared light, fluidizes the mitochondrial matrix fluid, makes them lower in viscosity. This goes back to the idea of the 4 phases of water of Gerald Pollack. Everybody knows 3 phases: liquid water, solid water being ice, water vapor being a gas, but there's a 4th phase, and that's a gel phase. And a lot of the water in a cell is in a gel phase. Think about it. If you crack an egg, you don't spill water out. If mammals are like 65% water, how come when you crack an egg you don't spill water out? How come when you get a cut you don't leak water? And the reason is because it's mostly in a gel phase, okay? And it's thought that when the calcium comes around, it will cause liquefaction of the gel phase, and that enables ATP synthase to spin faster and produce ATP faster. That's thought to be the mechanism. All right, so this is pretty impressive stuff. What this means too is if you have a diabetic, they should get their butt outside, walk around in the sun for 20 minutes. You get a little suntan, you get a little vitamin D, you'll get vasodilation from your nitric oxide precursors, your mitochondria will work better, and he's showing that your oral glucose tolerance, that your blood glucose will be lowered. So this improves your blood glucose control. It's a pretty cheap, efficient way. You know, God's way is free, and it works better than man's way to help treat diabetes, okay? So he's just going through some of the numbers here. And the paper's in the Journal of Scientific Reports 2025. Longer wavelengths. Remember, it's the longer wavelengths. Think of them like the longer wavelengths like AM radio. They can travel longer distances than FM radio, for example. UV light, like I said, causes suntan, sunburn, release of nitric oxide precursors. Blue light, coming up next is, to let you know it's daytime. Red light and infrared light are the ones where you're getting penetration through the body and improved mitochondrial function. Normal sunlight has a very wide spectrum. It has about 300 to 3,000 nanometers is its wavelength range. Versus these LED lights, they're made to be very narrow. The reason why they're more energy efficient is all that electrical energy going into them is then made to produce only visible light. So they're not so-called wasting energy, they thought, on things below or above that. But now it's turning out that it is a problem because we benefit from this infrared light. It improves our mitochondrial function, improves our blood glucose control. If you have a big building like a skyscraper or something, they're going to use infrared blocking glass because they don't want to be losing heat. It's cheaper to heat the building. But then the person who's standing in there isn't going to get that infrared light. They're not going to get the benefits of it. Okay, there's something called the abscopal effect, meaning that mitochondria affected like in a patient's back. You could just put it in a little box and have the light exposed to their back, and they'll get improved mitochondrial function in their eyes and other parts of the body. The retina of the eye has the highest concentration of mitochondria of any body part. Okay, so the abscopal effect means you could just shine light on their back and it'll improve their visual function. So somehow it seems the mitochondria are able to communicate with mitochondria at a more distant location and improve their function as well. The long bottom line of all this is that we benefit from sunlight and should get more of it in the daytime if possible. Nighttime's a different issue, where nighttime you want to avoid blue light. Okay, but the big benefit of the sunlight is this long spectrum of wavelengths such that you get this red light and this infrared light that improve mitochondrial function. That was the big point of it. And that's thought to be a big deal here. Okay, here he talks about it, that this will promote mitochondrial function, which seems to be able to help counteract the decline with age. It's especially important in the eyes because you have such a high concentration of mitochondria in the eyes as well as in the brain. Okay. Here's one of the first line. Long wavelength red light can extends beyond the human visual range, infrared, penetrates deeply through biological tissue, goes all the way through us, through and through. So let's see if there's anything else to say here. Anyways, that's the main point. I think I got maybe one more page or part of the article. Like I said, it's about 600 to 1,000 that'll pass through the body, okay? And 660 to 1,000, they're improving mitochondrial function. He thinks this will help people with better aging, better vision, better blood glucose control for diabetes. I can tell you, I think he's right, and there's a lot of other people who've read these papers. They're very impressive, and I'm currently reading his other papers too. It's good, brilliant work, okay? And it's easy to confirm it, okay? Let's see. There's a systemic impact from light exposure to just part of your body. You don't even need to expose your entire body. Okay. Our visual range is only about 400 to 700. Okay. But it's when you get up over, about 650 to 900 is where you get the best wavelengths that seem to be helping us. All right. That's all I'm going to mention in this for today. But I'm just letting you know there's real reasons why sunlight's really good for you beyond vitamin D.